Understanding Physics. This video is for assessed practical number 10, which is force on a current. So this is the equipment that you'll need. You'll need some leads, and I would suggest just holding the lead that goes inside the magnetic field. Just hold it. Okay, talk a bit more about that later. There are special, you can try clamping it and stuff. Just make sure it's straight, pull it tight, make sure it's at right angles to the field, and just hold it. Okay, you need some these slab magnets. Yeah, they come with motor kits, slab magnets, and they come on the steel yoke to hold them. You need a top pan balance. You need a variable DC power supply, and you'll need an ammeter. Okay, so this is your equipment. So hold the wire in the field at right angles to the field. Zero the balance, so working as a team. Zero the balance, then put a current through the wire so that an upwards force acts on the wire. And so from Newton's third law, if the wire is being pushed upwards, then the magnets will be pushed downwards, and you'll get a reading on the balance. And then the reading on the balance, you can do, mg to work out the force. Okay. As we're just looking for the relationship, you could just leave it as grams on the balance. It doesn't matter. Or you can work out the force in newtons. But basically, the wire's pushed upwards, the magnets are pushed downwards, and the force is proportional to the reading on the balance. We are supposed to investigate the relationship between the force and the current and the field strength and the length of the wire in the field. So your job is to investigate the relationship between the force and those three things. So current is straightforward enough. I would do it kind of from 0 to 3 amps, half an amp at a time. Will give you enough readings. Just have it turned on for a couple of seconds, as long as you need to, so that you can adjust the current and then take a reading on the balance. Because when you get up to 3 amps, that's quite a large current going through the wire. So the wire's going to start getting a little bit hot. So if you're holding it, it will feel a bit warm. And we don't want to knacker the power supply. So just have it on for a few seconds, as long as you need to. So you can take readings of current against force. Field strength, what you can do with this apparatus is you can double the strength of the field by putting another pair of magnets on. Be careful with the polarity of the magnets, so that you've still got north pointing inwards on one side and south pointing inwards on the other. You'll know what I mean when you start playing with it. You'll know what I mean. Okay, so you can double the strength of the field. I don't think you couldn't treble it really. You probably won't have enough room to do that. The length of the wire, again, you can double the length of the wire with this apparatus by using another yoke with another pair of magnets on. So you've got twice the length of the wire in the magnetic field. Again, be careful with the polarity of the magnets so that all the fields are in the same direction. And I would ask my students to do these graphs. So force against current with B, one pair of magnets producing the field, and then 2B, or not 2B, with 2 pairs of magnets producing the field, and then force against current with 1 length of wire and then double the length of the wire, so 2L. And if you're getting straight lines for the current, great. And if you double B, the force is about twice as big. If you double L, the force is about twice as big. With this apparatus, that's all you need to do. There are cleverer bits of apparatus, a thing called a current balance, but they're very expensive and they're not necessary. What I've asked you to do here is enough. Now, looking at these, pretty straightforward. Take measurements, use digital instruments, so you're using a multimeter, take measurements, make circuits, very straightforward.